All right, let's talk about we need to talk about a few extra things when it comes to Lewis structures. So the first thing is what's called formal charges. And this basically lets us determine, I mentioned in a previous video, secondary criteria for evaluating resonance structures. Formal charges is one of those. So a formal charge is similar to an oxidation number. It's the same kind of idea where you can calculate the formal charge for each atom in a molecule. Let's take carbonate, for instance. And the sum of the formal charges is going to equal the charge in the molecule. So for carbonate, that's a 2 minus. Okay? And the way you calculate it is the formal charge is equal to the number of valence electrons minus the number of lone electrons plus the number of paired electrons divided by 2. So if we look at these oxygens, okay, we've got on each of them, they're the same. So 2, 4, 6 unpaired electrons and 2 paired electrons. So the formal charge is 6, the number of valence electrons on oxygen, minus number of lone electrons plus number of paired electrons divided by 2. So it's 6 minus 6 plus 1, 6 minus 7, or minus 1. So both of these oxygens will have a minus 1 charge. Okay, well, let's look at this lower oxygen. Valence electrons, 6 valence electrons, and I've got 4 unpaired electrons and 4 paired electrons. So 6 minus 4 plus 4 over 2, or 2, is equal to 0, right? 6 minus 6 is 0. So that will have a formal charge of 0. And then the carbon, which has 4 valence electrons minus 0 unpaired and 8 paired, will have a formal charge of 4 minus 0 plus 8 over 2, or 0. So, in this manner, you can calculate all the formal charges. I think there's an easier way to phrase it, though. So, each line represents 2 paired electrons. In other words, one line is equal to 2 paired electrons. So, the number of lines equals the number of paired electrons divided by 2. And each dot represents 1 unpaired electron. So the number of dots equals the number of unpaired electrons. So the way I like to think about it is the formal charge is the number of valence electrons minus the number of dots plus the number of lines. This is the way I like to do it because it's super easy. So we go, boom. Okay, oxygen, 6 valence electrons. 6 minus 1, 2, 3, 4, 5, 6, 7. That's going to be a minus 1. This oxygen, 6 minus 1, 2, 3, 4, 5, 6. That's going to be a 0. 6 minus 6 is 0. And then carbon, 4 minus 1, 2, 3, 4. Formal charge of 0. So I would highly commend this method to you because it's very straightforward. So as you can see, the sum of the formal charges, 0 plus minus 1 plus minus 1 is equal to minus 2. So the sum of the formal charges equals the charge on the molecule. Now, some important rules for formal charges, and this is where this helps us evaluate molecules, because you could conceive of molecules where there are multiple different ways to draw it, where you are fulfilling the octet rule, but they'll have different formal charges, okay? So here are some rules. You want the structure with the fewest and smallest formal charges. Similar charges, pluses and minuses and minuses, should not be adjacent, so they have to be separated by one or more atoms. And then negative charges should be on the most electronegative element. We'll talk about electronegativity later, but basically, for the further up and right, kind of like ionization energy and electron affinity, the further up and right you go, the more electronegative something is. So, let's look at an example. There are 3 possible ways to draw the sulfur carbon nitrogen molecule that all fulfill the octet rule. Okay? So sulfur 2468, carbon 2468, nitrogen 2468. You can check for all of these. And for all of these, you can check formal charges and find that the formal charge is equal to minus 1. So sulfur, we have 6 minus 1, 2, 3, 4, 5, 6, 7, so minus 1. Carbon, 4 minus 1, 2, 3, 4, so 0. Nitrogen is 5 minus 1, 2, 3, 4, 5, so 0. Here, sulfur is 6 minus 1, 2, 3, 4, 5, 6, 0. Carbon's 4 minus 4. Nitrogen's 5 minus 1, 2, 3, 4, 5, 6, or minus 1. Here, sulfur is 6 minus 1, 2, 3, 4, 5, so plus 1. Carbon is 4 minus 4, 0. Nitrogen is 5 minus 1, 2, 3, 4, 5, 6, 7, minus 2. Okay, so this one right away, you can see, oh, that has more formal charges than either of these two, so this is the worst. Then we have to decide between these, which look very similar, right? You have 0, 0, minus 1, 0, 0, minus 1, so they're practically the same. So then you say that negative charges should be on the most electronegative element. So which one's more electronegative? You look at the periodic table. Nitrogen is higher up than sulfur, so nitrogen is going to be more electronegative, so it's better to have the negative ion on nitrogen. So this is the preferred. It's not to say this is correct, it's to say this is the preferred form. Because, as you'll see, you can't, because these are all valid, you can't actually freely switch between these. But this is the preferred form. So if you looked at the percentages, you'd see it'd be like a high percentage of this, then a little bit of this, then a teeny tiny amount of that. So let's do some practice. So calculate the formal charge on each atom in CO. So we do C. Okay. So 1, 2, and then we have to. So this is where this gets tricky. So if we move that in, right, and we pair these two together, then you get carbon, triple bond, oxygen, 1, 2. The other way to do it, and this is one, in the weird cases like this is where the other method is going to be better. So I've got 10 total valence electrons. We'll go 1, 2, 3, 4, 5, 6. So 2, 4, 6, 8, 10. So we'll just have to do that, and you get, again, you get back to that. Okay, so calculate the formal charge. Carbon 4 minus 1, 2, 3, 4, 5, so minus 1. Oxygen is 6 minus 1, 2, 3, 4, 5, so plus 1. So this is one where the negative atom, the negative charge is actually on the less electronegative atom, but because this is the only possible way to get both with an octet, this is what it ends up being. Calculate the formal charges of each atom in, this should say CO3 2 minus carbonates. So carbonates, we did just look at, right? So this is going to be 6 minus 1, 2, 3, 4, 5, 6, 0, 4 minus 4, 0, 6 minus 7, negative 1, 6 minus 7, negative 1, for a total of negative 2. Oh, I did nitrate. Whoops. Haha, funny. All right, well, NO3 minus. So again, we can look at this one here. So oxygen is 6 minus 1, 2, 3, 4, 5, 6, 7, so minus 1. Nitrogen is 5 minus 4, so plus 1. Oxygen 6 minus 6 is 0. And oxygen 6 minus 7 minus 1. So you have minus, plus, minus. So plus 1, minus 1, minus 1, plus 0 is minus 1.